Your compass has never once pointed at the true North Pole. It drifts 50 kilometers a year. Every hiker, sailor, and hunter who has ever trusted that little arrow has actually been following something stranger. A magnetic pole that wanders through the Arctic on its own private schedule, no map required. It has never sat still, not for one single day in recorded history. So what exactly is that needle chasing? Here's the assumption almost everyone makes without even thinking about it. Somewhere up at the top of the globe, there's a fixed point, the North Pole, and a compass needle is basically a tiny detector built to sniff it out, like a nose pointed at a landmark on a map. It feels obvious. It's taught early, and it's wrong in two separate ways at the same time. First, the needle isn't pointing at the geographic North Pole at all. It's pointing at the magnetic North Pole, a completely different location, currently sitting out in the Arctic Ocean, hundreds of kilometers from true north. Second, that magnetic pole isn't fixed in place. It has been creeping across the map for over a century, and in the last few decades, it's sped up dramatically, sliding from northern Canada towards Siberia at more than 50 kilometers every single year. Scientists still aren't entirely sure why the drift accelerated when it did. So why does a little needle chase a wandering point at all? The answer starts 2,000 kilometers beneath your feet. Earth's outer core is a churning ocean of molten iron, thousands of kilometers deep and unimaginably hot, constantly sloshing and swirling. Moving liquid metal generates electric currents, and electric currents generate a magnetic field. The exact same trick as current flowing through a wire wrapped around a nail. That field wraps the entire planet, with lines looping out near one pole and back and near the other, as if Earth were one giant bar magnet tilted inside its own shell. A compass needle is nothing more than a sliver of magnetized metal, balanced on a pin so it can spin almost frictionlessly. Drop it into that planet-sized field, and simple physics takes over. The needle twists and settles until it lines up parallel to the field lines passing through it, the same way a leaf dropped into a stream turns to point downstream. It isn't sensing a place at all. It's just obeying the pull of a force field it can't see. That drifting magnetic pole isn't some trivial rounding error either. Navigators call the gap between true north and magnetic north the declination, and in parts of Alaska or northern Siberia, that gap can swing your compass reading more than 20 degrees off course. Pilots, sailors, and land surveyors all carry updated declination charts for exactly this reason. The correction that was accurate 5 years ago is already stale because the pole simply refuses to sit still. Even runway numbers at airports occasionally get repainted to keep up with the drift. And the field itself isn't some ancient, unchanging feature of the planet either. It has flipped entirely, north and south swapping places, hundreds of times across Earth's history, on average roughly every 200,000 to 300,000 years, though the real timing is wildly irregular and sometimes gaps stretch far longer. The last full flip happened around 780,000 years ago, which means, statistically, we're overdue. On a geological clock, though, overdue could still mean many thousands of years still to go. So next time you glance down at a compass, remember what it's actually doing. It isn't pointing at a place on a map. It's going limp in the pull of a churning ocean of molten iron, 2,000 kilometers beneath your feet, generating a field that drifts, wobbles, and someday will even flip entirely. It's not a landmark. It's a live signal broadcast from the middle of the planet, and you're holding the receiver. That's the whole point of this channel. We keep cutting things open. Stick around.